Moodle, all the voice recordings. Listen to them. Yeah, listen at least. Okay. All right, so logs are another way to rewrite a problem, an exponential problem, a problem with exponents. So this is why you really need to know your rules for exponents. When do you add? When do you multiply? When do you subtract? Okay, so logs are another way to rewrite a problem with exponents. They are the inverses. Remember how we figured out inverses on the last chapter? Well, we're going to do inverses for exponential problems. Okay, so this little number right here, or letter, is your base. This is the answer. This is your exponent. So in the inverse, look, if I write it as log base b, y equals x, I'm really saying this, b to the x equals y. It's just another way to write an exponential problem. Yep. Yes. That was your little subscript of b. So there's your base. Okay, so our base is what has our exponent when we flip-flop them around. Okay, they are inverses of each other. They're another way to write the same information, just having it placed differently. Why do we want to do logs? Because sometimes we want to figure out what our exponent is going to be. And the only way that we can figure out the answer to our exponent is to rewrite it in log form. Okay?
So like when you're graphing this, like you have more instead of like just guessing with the chart,
Mm-hmm.
you have like exact.
You could use your calculator to help you figure it out. Now your calculator will only do log in base 10. But we're going to do problems with different logs, bases of 4 or 2 or 12. Okay? Yes. Yes. Okay. All right. So if I give this to you in log form and I want you to rewrite it in exponent form, you start by asking yourself always 3 questions in this order. What's the base? And what's the exponent? And then finally, what's the final answer? These 3 questions will help you rewrite a problem that's given to you in log form and rewrite it in exponent form. So look at this problem. Log subscript 2, 8 equals 3. What's the base? What's the exponent? What's my final answer? Is 2 to the third equal to 8? So you've just rewritten it in the inverse form. Right, these are inverses of each other, exponent form or log form. So if I give it to you in exponent form, the inverse is log form, and vice versa. Okay? All right, so look at the next one. What's the base? What's the exponent? What's my answer? Is anything to the 0 power 1? Okay? Here we go. What's the base? And it's this 12, right? The exponent is? And the answer is? What's the base? 1/4. What's the exponent? Yeah, so I got to put that 1/4 in parentheses because all of that's being raised to the -1. If I just write 1/4 to the -1, I'm assuming that only the 1 has a negative exponent. Do you understand that? And is 1/4 to the -1 positive 4? Sure is, because you flip it, right? A negative exponent you have to flip. All right, now we'll go the other way. And so you ask yourself still the same questions. You start by writing the log. And you ask yourself, what's the base? So you put this little 3 down here. It's a little bitty subscript. And then you have to say, you kind of flip-flap these. What's the answer? What's the exponent? Right. Yeah.
Are they going to fix problems where it's not right?
No. Okay. So log base what? Of equals, right. So remember, you set it equal to the exponent when you're rewriting it as a log. Okay? Log base of equals, yep. It's making sense? Okay, just a manipulation. Here we go. Log of 1/2, whose answer is an exponent of -5. Okay? Okay, so now we're going to simplify this. So we kind of want to think about setting these maybe equal to x or y, or we'll make it y. Since I have x's in some of the problems, we'll change it to y so we don't get confused. Okay, so we're going to say, we're going to rewrite it in exponent form to help us see what this answer or what this exponent is supposed to be. I'm saying 5 to the y equals 25. That means 5 to the y equals 5 to the squared. So what does y equal? 2, right? Doesn't that make sense? If 5 to something has to be equal 5 to the second, if the left side has to equal to the right, don't the exponents have to be the same if the bases are the same?
Yeah.
I mean, think about it even from this point. 5 to what power is 25? Okay. But here's why. 5 to the y, and 25 is written as 5 to the second. So that means the y has to be equal to the 12 if the left side equals the right. Huh? All right, we're going to set this equal to y. I don't want to use x because there's already an x in the problem and I don't want to confuse myself. So we're going to say 7 to the equals 7 to the -3x, right? Right? So what does y equal? Yes. Mm-hmm. This is my answer. Because if 7 to something, I mean, think about this. 2 to the second has to equal 2 to the unknown. What does that unknown have to be? It has to be. Otherwise, the left side doesn't equal the right. If it's 3, then I'm saying 4 is equal to 8, and that makes no sense. Okay. Okay. So 2 to the, we're going to set this equal to y, and we're going to say to the y is equal to 64 to the, okay. My bases have to be the same. So let's rewrite 64. What is 64, Meg? Oh, what is 64? So, let's make it a base of 2. We got to make the bases the same. So 2 to the y equals 2 to the 6th raised to the x, right? I'm just rewriting 64 as 2 to the 6th. So 2 to the y is equal to 2 to the what? 6x. So what is the answer to y? What does y equal? 6x.
To make the bases the same, would you just do
You got to think in your head. I have to have a base of 2. 2, 4, 8, 16, 32, 64. Okay?
So then if you bucket it and manipulate 2 to the power of 6x.
Uh-huh. Okay, so ln and e. Remember on your calculator, Above the ln key was the e key. They're inverses of each other. So the only base that the ln can have is an e. log can have any other base. It can be a base of 5. It can be a base of 7. It can be a base of 2. The standard base, if nothing is written, is 10. So if I give you log of 8, the understood base, if there's nothing written, is 10. So this would say 10 to the x equals 8. This 10 is understood to be the base. If no base is described or stated, the understood base is 10. Okay? That is, no, that's for log. So log, that's called the log. ln is called the natural log. ln is the natural log. Okay. So we're going to set this equal to y. Now, is this an, think about this, is this an exponential form or is this in logarithmic form? It's an exponential form. So what's the inverse going to be? Log form, right? And so we're going to ask, we're going to rewrite this. We're going to rewrite this. We have to use the ln. What is the base? No, the base is e. That's the only base that you can have with natural log. Of y equals, we have to set it equal to the exponent. What's in the exponent? No? ln 20. Because e only goes with ln. Those two are the only ways to write each other, not log. E does not go with log. Okay? All right, what does y have to equal? Nope. If the ln of e of y is equal to the ln of understood e of 20, then what does this argument have to equal? 20. It's all it is a manipulation. Because what is the only base that ln can ever have? E. And the only way you could write log with e is ln. They are always attached. E and ln are always attached. They're always inverses of each other. What? So, we know that exponentials are graphed like this, right? LNs are graphed like that. They don't have a y asymptote, they'll have an x asymptote. And it'll never cross an x asymptote, wherever that x asymptote's going to be. No, an x asymptote. If I give you 10 to the x, this was always our asymptote, wasn't it? That's a y asymptote. It's going through a y value. Right? So the other one's going to have a vertical asymptote, which is an x value that it goes through, so it's an x asymptote. Right. Okay? All right, let's look at the next one. So this has a base of what? Which means if I'm going to rewrite it, what do I have to rewrite it with? Okay, so we're going to ask the three questions, aren't we? We're going to say the ln of e, it's your base, the ln of e, and what do we put in here? X plus 2. This is always your, oh, no, my bad, of y, right, equals x plus 2. If we're writing in a log, this is our base, this is our answer, this is our exponent. What's the base? No, that is a log. That's the log. That's the way you write log when a base is e. This is the way you write log when the base is something other than e. They both say log. This is natural log, Rachel. This is just log. Okay. Am I going to use LOG or LN? for this next one? You don't. That was just a rewriting one. Okay. No, y doesn't equal x plus 2. There's not an ln on the other side, right? Because we just rewrote it. We rewrote it. We said the ln, which we have to use because the base is e, of our answer equals our exponent. Okay? So am I going to use ln or log for this next one? Log. And so I'm going to put, what is the base? Okay, we have to be careful. If we're going to rewrite this, we need to make sure that the 3 is on the other side. Nice job. So we want to really write this as y plus 3 equals 2 to the x. Because we want to be able to identify our exponent. Our term with the exponent has to be by itself. So that 3 gets to move to the other side. So, what do I put here? Do I put the answer or do I put the exponent here? We put y plus 3, and what does a log always equal? The exponent, which is x. We're just rewriting these. I'm just rewriting it. You've got to ask your 3 questions, and you need to know log, base, answer, exponent. That's where everything goes.
Why is it log and 2 then minus 3?
Because I need to have this 2 to the x isolated. I don't know where that 3 is supposed to go. It's not an exponent. It's got to be part of the answer then. Okay. And then in exponent form, you have base, exponent, answer. So this is log form, log, base, answer, exponent. This is exponential form, base, exponent, answer. That's where there's 3 pieces of information. That's where they go, depending on which form. Huh? Base, exponent, answer, right? Isn't this 4 to the 3rd equals 64? Base, exponent, answer. So this would be log 4, 64, 3. Okay? Okay. Y equals 4 to the x. We just learned how to graph these, didn't we? What's the domain? Domain, x is an element of the reals. What is your range? Y is greater than 0. Okay? So we do our little XY chart. If x is -1, we get 1/4. If x is 0, we get 1. If x is 1, we get 4, correct? So, -1, 1/4, 0, 1, 1, 4. And where's our dotted line? Right here, correct? That's our dotted line. Mm-hmm.
But are we putting it to the graphs where the asymptote?
Okay, let me finish this problem. Okay. All right, now it says do the inverse. State the domain and the range. So what did we learn when we're trying to write an inverse? What's the first thing you always do? You switch to the y and the x. So if this is saying y equals 4 to the x, then what we really want to say is 4 to the y. And we always try to solve for y. But if this is an exponent form, how do I solve for y? Log of base, whose answer is equals, there is the inverse. So what is the domain of this? Is and y is element of the reals. Remember, they flip-flop. The domain and the range become the domain and the flip-flop of the range and the domain. And what points are we going to graph? Which is 1/4 and 1 and 4 and where is our asymptote going to be? So y-axis. So if I have 1/4, I'm going to be down at -1. And if I'm at 1, I'm going to be at 0. And if I'm at 4, 1, 2, 3, 4, I'm at. So this approaches here and goes forever this way. Exactly what we did in the last chapter. Ellen? Because you've got to switch the x and the y. That's always been the first step that we do when we find the inverse, right? And we want the y, we want it set equal to y. Ellen, if we just rewrote it like this, we would have had log 4 y equals x, and we really don't have it so that we're setting it equal to y, which is why you got to switch the x and the y. Okay? Haley? You mean you can pass the original, the first asymptote, yes, because you've got your asymptote's the blue one. Does that make sense? So the original asymptote was for this one. Come on, Rachel, wake up. The new one is this one, so we don't ever pass the new one. Okay? Yes. Mm-hmm.
So, like, if your normal version, the range is y is less than 0, like
Then we'd be on the other side.
yeah.
Mm-hmm.
It would just be
Mm-hmm.
for the inverse, how do we write it on the graph if it's greater than 0?
Whatever this tells you.
So the asymptote is
It's an asymptote.
asymptote.
So my asymptote was y greater than 0, which is this red line. And so our asymptote for the inverse has to be x greater than 0, which is this.
Okay, so do we just do the dotted line above the 0? Or
Well, it's not. It's supposed to be on the x-axis. Okay. All right, let's try the last one. So we're doing the same thing for this one. You do not want to graph in ln initially. You can't generate points if it's an ln. So if I'm asking you to graph the ln, find the inverse, get all your information, then flip it for the ln. Does that make sense? It's easy to graph in an exponential. You can't figure out, I mean, how do you know how to graph this? This doesn't even make any sense. So let's come up with first, let's find the inverse. So if given ln or log to graph, what you want to first do is write in inverse form, which means that's an exponential. Okay? So if I want to start with y equals ln of x minus 5, and I want to do the inverse, then I'm going to say x is equal to ln of y minus 5. And then the inverse of log is exponential. So I ask myself the 3 questions. Ask the 3 questions. The first one is, and what is my base if it's an ln? E. There's an understood E when the base is ln. And then my second question is, what's the exponent? What's my exponent? Of course there is. Where's my exponent found if it's written in logarithmic form? X. And what is my answer supposed to be? And so now what we're going to do is we're going to finish solving for y, and we're going to say e to the x plus 5 equals y. Now it's the inverse, right? So we're going to put that -1 there. All right, now we can do our chart. We can come up with our chart. We can come up with our domain and our range, and then we can go back and graph the natural log. So what is my domain? X is element of the reals. If it's an exponential form, it's always the element of the reals, correct? What is my range? Y is greater than 5. How do we know that? You've been missing this, but here.
Okay, now it's going to be.
It's whatever this is.
Okay.
That's kind of your dotted line. So we know at 5, we've got our dotted line right here. Let's do our little XY chart. Get your calculator out. Is this a growth or a decay problem? And you know that because exponent is positive on an E, right? And we learned that also yesterday. Okay, so if x is -1, what are you going to get? On your calculator, what do you get? E to the -1, and then you add 5. 5 point what? Okay. If x is 0, then I'm going to get 6, right? And if x is 1, I'm going to get something like 7.7 maybe? Okay. All right, and so I know that I'm way up here on my graph. I'm above my asymptote, right? And it's growing, so at -1, I'm a little bit above 5. At 0, I'm at 6. And at 1, I'm almost at 8. So this was the logarithmic. The exponential, correct? So the logarithmic then is the flip, isn't it? Yeah, well, no, the exponential is the inverse because we were given the logarithmic. So what is my domain? What's my domain? X is greater than 5. What's my range? Y is element of the, because these flipped, right? Right? And my chart that I want to use, because it's easy to generate in an exponent form, my values that I use are going to be 5.36, -1, and 6, and 7.7, and 1. And so we're going to put our asymptote at 5 on the x-axis, aren't we? Can I cross the blue asymptote? Yes, I can cross the blue asymptote because I'm not graphing the exponential, I'm graphing the logarithmic. So I got to stay to the right of the green one, yes? Does that make sense? I'm going to stay to the right of the green asymptote because that's what I'm graphing now. So at 5.36, I'm going to be at -1. 1, 2, so that's like right here. And at 6, I'm at 0, and at 7, between 7 and 8, I pop up to 1. So I'm approaching from the asymptote and going out. Does that make sense? Okay. All right. The end.